All right, so for the entire first page of the quiz, this is the position function that you were given. And we're told that times are positive. So just from 0 onwards, it's not capped anywhere. Your interval is just from 0 until forever. So number 7 is asking, when is the particle slowing down? I'm going to need to also do question 4 to do this, because these are all related to each other. They're all based on this same position function. So I'm going to go back and do question 4 first. 4 says, at what values of time does the particle change direction? So in order to change direction, it has to stop. And so that's going to be velocity equals 0. So I have to find where the particle stopped first before I can see where it changes direction. So velocity is going to be this derivative. That would be 3t squared minus 3, and we're going to set that equal to 0. And so we'll add over 3, and then divide by 3, and then square root. So we get time 1 second. So when we look at number 7, it's asking for slowing down. You have to look at both velocity and acceleration. So I'm going to make a number line for velocity and acceleration. And I have to put this 1 second on my number line. So I'm going to put 1 right there. And so I'm going to pick a number in this interval and plug it into velocity and see if it comes out positive or negative. I don't need to work it the whole way out. I just need to see the sign. So I'm going to try a half. So if I plug a half into velocity, a half squared would be a fourth, times 3 would be 3/4, minus 3 is going to be a negative result. And then if I plug in a number bigger than 1, so like if I try 2, it's going to be 4 times 3 is 12, minus 3 is 9, so that is positive. So this shows the particle changes direction at 1. It moves to the left and then it moves to the right. And so now I'm going to need to get acceleration. That's going to be the derivative of velocity. So if I do this derivative, that will be 6t. And no matter what number I plug in bigger than 0, this is always going to be positive. You would have to plug in a negative number, something over here, to get a negative result, and we don't have negative time, so this is always positive. And so the question was, when is the particle slowing down? That's going to be this section right here. So your answer is from 0 to 1, because velocity and acceleration, because velocity and acceleration are opposite signs there. And just to talk a little bit about those justifications, this is going to sound like I'm being awfully picky, but on the AP exam, they won't give you credit if you don't write it correctly. So if you say because they are opposite signs, like if you say they or it, they won't give it to you. So don't say they or it. Don't use pronouns. You're going to have to say velocity and acceleration. So you have to mention those. Also, if you don't say signs, if you just say they are opposite, they won't give it to you because they aren't opposite. It's their signs are opposite. So just make sure you write it exactly like I'm showing you, because if you leave any part of that out or change it, they will not give you the points. So keep typing in the chat, guys. I'll do a few more of these if you would like. So look through. Is there another one that you guys want me to go over for you? All right, 13. I'm going to need the graph that went along with that, so just hold on a second while I draw this real quick. It'll only take me a minute. All right, so this is the graph of velocity, and 13 is asking, where is the speed increasing? So it's kind of what we were talking about here. This one said slowing down. Speed increasing is speeding up, but we're going to do the same thing. We're going to make a number line for our velocity and acceleration and compare the signs. Now this interval was capped at 8, so I'm going to have to stop it there. And any number where this graph touches 0 or turns around, I'm going to need to include on my number line. So I'm going to need 2. And then right here, I'm going to need 4. And then I'm going to need 6. So this is the graph of velocity. So velocity is going to be positive where this is above sea level, negative where it's below. So our velocity is positive from 0 to 2, and then negative from 2 to 6, and then positive from 6 to 8. So that's just the graph being above or below the x-axis. Now acceleration is the derivative of velocity. That's the slope of velocity. So now we're looking at increasing and decreasing. So acceleration is negative from 0 all the way until 4. This graph is going down from 0 all the way until 4, so negative. And then acceleration is positive from 4 to 8. And so this question asked, when is the speed increasing? That would be when these are the same sign. So that is going to be from 2 to 4 and from 6 to 8, because velocity and acceleration are the same sign there. And again, you have to mention velocity and acceleration by name, and you have to say same signs. So just write the justifications literally exactly like I've shown you, and you'll be fine. Do you guys want to pick another one? Okay, I'm going to go ahead and stop this here. Oh, all right, there we go. 11A. All right, so 11, we were given this position function. All right, and we have time is in seconds, distance is in feet. Letter A says, when is the particle at rest? So that is going to be velocity equals 0. So I'm going to get this velocity, set it equal to 0. So the derivative is 3t squared minus 6t minus 9. And I'm going to go through and divide everything by 3 to make the numbers a little bit smaller. And then this is going to factor. So it will split t plus 1, t minus 3. I don't get a result from this because we don't do negative time. So if you wrote negative 1 second, I had to take off for that because we don't do negative time. So the only result we get is from this one. So time is 3 seconds. All right, last call for anything else on your quiz. Okay, I'm going to go ahead and stop this video then.